feasibility D, lepas tu feasible, so kita buat loop lain kan. Tapi kita kena check juga ke feasibility A, B, C tu.
Sebenarnya bila awak buat loop, contoh kan, loop kat sini, when there's a change in your load for your heat exchanger, there will be a change in your temperature. So when there's a change in your temperature, there will be a change with the feasibility. Kalau temperature dia berubah, dia jadi less than 10, ataupun less than your delta T min. So if this delta T min is 20, maka dia jadi tak feasible. So the simple way would be whichever temperature yang berubah, you must check for the feasibility. So kalau contoh ni kan, for the heat exchanger, lepas kita buang heat exchanger sini, heat exchanger semua ni berubah. So kita akan check. So macam tadi apa yang Akasha buat, dia kata okay, kita tengok temperature 2 ni in the loop kan. Tapi dia check juga untuk this punya feasibility. So yang ni memang kita tak boleh ubah, tapi we can change this. So macam Akasha explain tadi lah. But basically what's being said, bukanlah kita check semua heat exchanger, but kita check heat exchanger yang ada perubahan in terms of dia punya loading. So yang mana yang ada temperature yang berubah. Sebab tu bila dekat sini kau nampak I check for D dengan A. Sebab basically dekat sini sebenarnya dia berubah daripada yang asal ni. Sebab tu saya end up check juga macam tu. Tapi sebenarnya kita kena buat path awal lah. Loop path lah, macam tu sebenarnya better. Faham ke? Kita macam tak faham.
Faham.
Faham. So basically the rule of thumb would be check the heat exchangers that have changes for your load lah. Macam tu. Okay. So actually janganlah follow macam saya buat ni. Awak buatlah loop. Lepas tu dah lepas loop ni awak check heat exchanger. So buat macam Akasha tadi. So you dah dapat check heat exchanger tu, oh dia tak feasible. Terus kita buat. So ni tadi bukan D saja. So kita tengok feasibility B dengan feasibility A. So kita akan terus buat lah dia punya path. Macam tu. Okay. Any other questions?
Doktor nak tanya, kan yang part kasket tu kan? Selalunya saya tengok orang buat 2 garis, tapi katakan kalau saya buat 1 garis je, lepas tu belah kanan tu tulis first casket dengan second casket, boleh ke akan tolak markah?
Boleh. Just make sure
Boleh
it's clear lah. Boleh. So kalau awak nak jimat masa, yes you can do that. Ada certain orang dia buat dalam table je senang. So dia buat sebelah-sebelah. Tapi be clear lah. Tulis itu, you have to write lah macam tu lah. Tulis first cascade, second cascade. And then kalau awak nak tulis QH min, QC min, kalau awak macam takut orang confuse, awak bulat lah tulis arrow ke QH min, QC min. Supaya at least the examiner dia tahu lah. So yes, even if awak nak buat, nak tulis dia punya heat exchanger network, nak buat sekali pun tak ada masalah. As long as it's clear. So biar orang tahulah apa yang berlaku. Okay, any other questions? Let's see. Macam mana nak ambil temperature untuk check feasibility. So hopefully that's a bit clear lah sekarang. A bit complicated, hopefully. So yang dapat 2 loops ni very good lah you guys yang dapat 2 loops. I don't understand how to find the loop. So hopefully boleh nampak. If you want to do the path relaxation, is it necessary for us to choose heater that is one stream with heat exchanger? So loop ni, remember dia macam Akasha sebut juga tadi, you cannot dekat tengah-tengah ni tau. Dia mesti sambung the entire length of the heat exchanger. So macam mana you guys nak make this logical? Cuba fikir kan, kalau kita ada heat exchanger dekat dalam plant kita kan, as an engineer, boleh tak kita tiba-tiba macam tengah-tengah dalam heat exchanger tu kan? Heat exchanger tu panjang ni kan, tengah-tengah heat exchanger kita ambil stream dia. Tak boleh kan? Sebab the heat exchanger is a unit itself. Dia macam satu unit on its own. So it must go through the entire unit. Sebab tu you must go through semualah. Kalau path pula, it doesn't matter which heat exchanger you use. It doesn't matter which utility ataupun heat exchanger you use. Yang penting dia kena lalu the entire heat exchanger juga. So kalau macam ni dia nampak satu je lah. Contoh kalau buat path dekat sini. So you would get, you can do this. You can do this. Or you can also do this. Or you can also do apa lagi? Oh, tu dua tu je lah. Tapi macam Akasha sebut, cari path yang you nak ubah temperature. So contoh kan, temperature yang kita nak ubah adalah contoh dekat sini. Dekat atas ni. Lepas tu path kita pergi buat macam ni. Boleh ubah tak temperature dekat atas ni? Tak boleh kan? So make sure kita cari path yang mana temperature kita nak ubah. So kalau kita nak ubah temperature kat atas tu, maka kita punya path kena lah jadi macam ni. Contoh dia, macam tu lah. Okay. Big apple is better than Dunkin' Donuts sebab Krispy Kreme is superior. Terhibur sekejap. Okay, cool. So I guess that's all for this tutorial. Any final questions? No? Okay. Okay, Alhamdulillah. Thank you very much everyone. So macam mana semua nak break kejap ke before kita continue?
Boleh continue je.
Okay, boleh continue So Alhamdulillah. I understand loop and path ni dia kadang-kadang very confusing. But if you actually understand the very basic of it, it should be fairly straightforward lah. Asal kita dapat buat dia punya loop, you can remove this policy exchanger. So jangan buat dia tengah-tengah. Kalau you tak dapat loop tu, that means there might be something wrong lah, sebab patutnya boleh dapat loop lah kalau soalan tu mintaan.
Doktor,
Ya.
kalau kita buat satu loop je tadi betul je kan? Ke kena buat dua loop juga?
Betul, tapi marks tak penuh lah. Faham ke? You don't get the final answer.
Okay.
Kiranya we always have to check for all the loops. So kalau kita punya, contoh kalau benda tu 25 markah, mungkinlah kita dapat 15 ataupun berapalah, ikutlah sebab ada loop lagi contohnya. So yes, your answer would be betul tapi dia tak final lah. Okay. So for this last part untuk chapter 2, chapter 4, basically, so I hope by now semua dah nampak lah macam ni kita dah dapat QC min, QH min, QC min, QH min dengan Q recovery for your energy targets. Kita dah tahu macam ni kita nak buat HEN. You already know how to do loop and path. So another thing yang kita nak consider for your total cost is your heat exchanger network area. So this one kita akan guna composite curve. So we're going to see macam mana it relates to your total cost. So kita nak tahu macam mana kita nak optimize this total cost and optimize the heat exchanger network area for a minimum total cost. Okay, so kita akan guna composite curve kita. So remember when I said dulu composite curve kita akan pakai balik. So this is when we're going to actually have to use it again lah. Okay, sorry. So as I mentioned last week, we have a lot of things that actually contribute to your capital cost. And what we actually, so this stuff you can read in your textbook lah, dalam buku textbook Robin Smith tu dia ada explain in detail, ataupun in other course pun ada juga. But what we've already looked at, this one is last week. So this one kita boleh minimize using loop and path. And basically kalau tadi dia suruh compare before and after, so kita sebenarnya akan tulis lah berapa number of units, because the more number of units means we need a higher capital cost. Dia macam kita nak install satu peti sejuk dengan 3 peti sejuk. Obviously kalau kita install satu peti sejuk, dia lagi murahan compared to 3 peti sejuk macam tu lah. Kenapa ada orang perlukan 3 peti sejuk? Mana tahu dia nak buat business kan. So kalau area ni pula, we're looking at the area of the heat exchanger network. So if the area is bigger, it requires a bigger capital cost. So this is an example lah of your cost variation with your delta T min. So last week kita tengok with the heat recovery, and so this is a picture for your delta T min lah. So you nampak with the delta T min yang sangat rendah, kita punya utility, hot utility kita mungkinlah, so this is your hot utility. So hot utility ataupun utility yang kita perlukan mungkinlah sikit sebab kita dapat recover banyak. So sebelum ni kita ingat, kalau dia punya delta T min is small, is better. Tapi sebenarnya what we don't see is that dia akan ada a larger heat exchanger area. And total area lah. So it's this value kat sini. Yang segitiga ni dengan yang segi 4 ni. So value dia sangat tinggi. Which kalau nampak if your delta T mean increases, your value would decrease rapidly lah. So what we're gonna do is, so apa yang kita biasa buat, so kita akan cari total cost. So this is your total cost. You're gonna find the smallest total cost, so it should be somewhere here. So mana smallest total cost, and that is your optimal value of delta T. Dan ni pun ada soalan last semester kot, yang ramai orang macam confused kan, kita nak ambil delta T min mana. So delta T min, you always want to choose the one which has the lowest total cost. So it's correlated to your smallest total cost. And usually when we're talking about the smallest total cost, we also want a smaller heat exchanger area. So that's why we want to learn macam mana kita nak dapat calculate heat exchanger area tu. So this is the second part of this chapter lah. So heat exchanger area ni basically kita akan calculate guna composite curve. And then basically the only difference is that kita akan ada utility streams lah. So utility streams tu akan make sure kita punya QC min dengan QH min kita 0. Okay, and I'll show this to you guys kejap lagi. So saya selalu tak faham kenapa dia punya delta ni hilang, tapi basically macam ni lah is the equation. So the network area basically macam ni kita nak calculate is your delta H over U times your delta log mean temperature difference. So apa yang kita akan buat, sebab dia ada very tedious, so we have to calculate satu-satu. So kita akan kira dulu dia punya delta T log mean, lepas tu kita akan cari dia punya delta H, lepas tu kita akan cari delta H over U, dan kita akan calculate dia punya total area. Okay, so ni these are the steps lah. So ni semua negatif. Saya tak tahu kenapa every time saya letak dalam video akan hilang. Tapi dalam notes korang ada kan, so that should be fine. So for this particular step, what we do, so untuk step number 1, biasanya kita akan construct dia punya composite curve. So what's important here is utility streams are included lah. So nanti waktu assignment jangan tiba-tiba macam, Madam kenapa saya tak dapat kan? So sebenarnya make sure kita punya utility kita include. So basically dia punya gambar akan balance kat ujung ni. Dia mesti sama. Dia punya graph. So kalau dia punya graph tak bertembung kat hujung tu means there's something wrong with our utility lah. Ataupun kita punya graph. Lepas tu kita akan follow these steps which we're gonna see today. Okay, semua okay ke? Untuk kita proceed.
Okay.
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 Alright, alhamdulillah. So if you guys need a break anytime, let me know lah. Okay. So this is the example of a question that we can use untuk calculate. So the difference with sebelum ni, satu is dia punya heat transfer coefficient ni. So be aware of the units lah. And the other thing yang berbeza dekat sini is kita terus ada kita punya steam and cooling water. So sebelum ni kita hanya tengok macam ni. Tapi now we tengok we have the punya steam and the cooling water. So dia ada supply temperature dia, target temperature dia, and cooling water dia, punya supply and target temperature, as well as the BCP value. So from all these value, kita akan plot kita punya composite curve. So ingat macam mana kita nak buat composite curve, we have to get all the hot streams, buat hot composite curve dia, buat guna cold streams dia, and buat cold composite curve dia, and we're gonna end up with something like this. So contoh kalau kita tak ada utility, yang line ni tak ada. Line ni tak ada. Sorry. Kalau line ni tak ada. So kita akan dapat kita punya QC min dengan QH min. So basically, bila kita dah ada dua ni, steam dengan cooling water, dia punya graph kat ujung tu akan at the same point, it ends at the same point. So contoh kalau dia punya kat sini tak bertembung, that means kita lukis graph tu salah. So it must be the same lah. So this is a big reminder untuk korang punya assignment 2 kot. Or assignment 1 juga. Okay. So bila kita dah construct, macam biasa. So how to construct, you can tengok balik lecture recording ataupun tengok yang lecture note for your chapter 2 untuk composite curve. After that, kita akan buat kita punya vertical line. So vertical line ni, so it's very important bila kita plot tu, kita indicate dekat mana. So kalau nak buat dot boleh, kalau saya suka buat pangkah. So buat pangkah macam ni. So when you can do a pangkah macam ni, you want to do a vertical line on each of those points yang ada. So you buat macam ni. Okay, so nampak ada pangkah kat sini, kita buat line. So buatlah line tu sampai habis. So these are the sections that you want to calculate the area. So to calculate this area, we have to divide it into these different portions. Okay. So kita akan, so portions ni akan jadi daripada atas lah. So 1, 2, 3, 4, 5, 6, 7. So kalau you guys nampak, basically wherever there is a point, it becomes a new section. Okay. And then kita akan, so we want to start our calculation. So remember, kita punya area equals to delta H over U delta T LMN. So this is how we want to calculate the area. But we have 7 different sections. So we have to calculate all of these values untuk semua section dan tambahkan untuk dia punya total area. So we're going to start with your delta T log minimum. So we want to calculate dia punya log mean temperature difference for each of those sections. So remember this all these different sections. So kita akan start dengan section 1. So kalau kita tengok section 1 ni, what we basically want to do is we're going to label mana TH1, TC1 dengan TH2, TC2. So TH1, TH2, TC1, TC2. So kita tulis lah. So basically it's just like reading dia punya graph lah. So kita punya TH1 berapa? Allah. Nampak ke skrin? Berapa TH1 dia? Okay, so 250. 2C1, TH1, TH2, sorry. Oh, hodoh ni line. So dalam 240 lah kot 210, 220, 230. So TH2 is 240. Okay. So like how we want to calculate the area, I like to see macam mana dia punya sebab dia sebenarnya we are going to use, so you can read in the textbook for more info, tapi kalau kita biasa guna is kita akan guna counter current punya HE. So kalau counter current punya HE, dia punya heat exchanger macam ni lah biasanya. So that's why kita punya TH1 dekat atas, TH2 dekat bawah. So kita punya TC1 kita kat bawah and TC2 kita kat atas. Yang ni selalu orang confuse lah. Tapi kalau kita tak nak confuse, you can just remember the arrow of your composite curve. So remember kalau hot composite curve dia ke bawah and your cold composite curve dia atas. So this would be your TC1 and TC2. So TC1 kita ambil line ni which is around berapa tu? 230. Yeah. 10, 20, around 220 lah kot 225. So sini 225. And then your TC2 would be 230. 230. Okay. So you akan dapat something like this lah. So this is your your first section. Okay. So you're gonna do it the same untuk kita punya first section and second section sampai 7 section. So macam ni kita nak calculate dia punya delta T LM is basically just use this equation. So your TH1 250 minus TC2 which is 230 minus TH2 240 minus TC1 225 over ln 250 minus 230, 240 minus 225. Okay. So you should get berapa delta TLM? So basically make sure adalah value ni. So senang untuk kita dapat dia punya value delta T. Nak mean temperature difference kan. Anyone dapat kira ke?
Tujuh
70.38.
17.38. So macam tu je lah the value. So bila kita dapat macam tu, thank you. So kita dah settle. So remember we want to cari. So this is for your TLM for 1 lah. So you would have 7 different value. Okay. So biasanya what we do is we gonna write it in a table lah supaya kita tak confuse. Tapi basically kita akan calculate untuk semua. So the next step, lepas kita dah dapat, so we have to have all the delta TLM untuk all these sections. So you guys can try that out. And then you want to identify you punya CP and your U. So kenapa CP and U? So remember it's the equation lah. It's your delta H over U delta TLM. So kita nak calculate dia punya CP is for your delta H kan. So basically what happens is that we want to identify dia punya CP and the U for each section and stream. So kita akan tengok balik how we plot our graph lah. So kalau kita tengok kat sini, you would see this basically for this stream, dia punya CP is from 240 to 250 yang ni kan. This value here, 240 to 250. So it would be, so sebenarnya kita akan check balik graph yang kita dah plot tadi. So it would be based on kita punya value of your hot composite curve. So if you remember balik, and I don't remember if I have it on this. Ada ke? Ada ke? Sekejap. So value dia akan dapat. Sekejap Okay. So value dia akan dapat for section. So for your CP, you akan dapat, so remember kita ada hot dengan cold lah. So hot, CP is going to be 0.15. And then for your U, you would be 0.001. For your cold, you get your CP which is 0.3 and your U is 0.008. So value ni yang ni lah tadi sebenarnya. 240. Sebab dia hanya, so kenapa kan, tak ingatlah saya ada tak. Kenapa is because kita tengok balik kita punya composite curve tu. So we identify. So basically kalau kita dah ada, kita lukis kita punya composite curve, should be kita dah dapat je lah pun dia punya value. Yeah, well, let me see if I can. So contoh dia kat sini lah. So contoh dia kan, so ni tadi bila kita buat, kita construct kita punya CC with utility stream, bila kita buat kita punya hot composite curve, kita akan lukis line. So remember balik kita akan ambil dia punya hot stream and cold stream. So kita akan lukis for untuk hot composite curve kita akan lukis dia punya line lah. So dia akan ada 1, 2, 3. So daripada 250 sampai 240 dia hanya ada this stream. So sebab dia hanya ada this stream, kita hanya guna 0.15. Okay. Tapi kalau untuk section 2, kalau untuk section 2, what you realise kat sini, for section 2, from 239 to 240 kan, you have kat sini kan, 239 to 240, kita ada dua. So kita ada ni dengan ni. So kita ada 0.15 dengan 7.5. So you have to identify your CP1 and CP2 lah. So kalau kat sini kita dapat So for this one, kita ada hot CP1, which is 0.15, and then kita ada CP2, which is 0.075. So 7.5. Okay, and kita ada U value kita lah. Coal ni pun sama juga. So coal is from the coal composite curve yang kita plot. And then kita dapatlah value dia. So kalau untuk section 2, this is only going to be one stream. So you have to look back dekat kita punya composite curve yang kita lukis. So when you already identify, you can then calculate your delta H. Delta H equals to CP delta T. So you have to add. So dia akan jadi sama macam apa yang you do in your composite curve punya step. So CP ni kita akan tambah. So kalau untuk ni tak ada masalah lah, tapi untuk ni dia akan jadi 7.5 plus 0.15. So dia akan jadi 7.65. Okay. And then you're going to times with your delta T. So delta T dia is going to be the difference kat sini lah. So contoh kalau sini is just 240 minus 239. So this sebenarnya 239 minus 240 lah. And value dia negatif sebab gradient dia ke bawah. But it doesn't really matter. So you get your delta H. Okay. So you're going to get the delta H untuk semua stream lah. So ni contoh dia tadi kan. So remember kalau kita nak calculate untuk setiap of this section, you will end up with 7 values lah. So dekat sini contoh dia macam saya sebut tadi lah. So delta H equals to CP delta T. So kalau this one is very straightforward lah sebab your value is only 1. So your hot you get 0.15 times 240 minus 250. Okay. Kalau kat sini dia akan dapat so you ada hot stream 1, which is delta H1, which you get 0.15 times 240 minus 239. And then you get, so this is basically 0.15 lah. And then for hot stream 2, you get delta H2, which is 7.5. So this value times 240 minus 239. Okay, and dapat 7.5. Okay, tapi untuk cold stream dia hanya ada satu CP, so you can just calculate. So sebenarnya bila kita tambah ni kita akan dapat 7.65. So samalah kalau kita dah tambah dua-dua siap-siap. Okay. And then this one is your delta H untuk your cold stream. So still for, this one is for 2 lah. So it will just be 0.3 times with your 225 minus 199.5. So this would be about 7.65 juga lah. Okay. So bila kita dapat buat benda macam tu, we can now calculate your delta H over U. Kenapa? Sebab equation dia area equals to delta H over U times your, divide by your TLM. Kita nak calculate this value. So this value kita akan bahagikan dengan this value. So macam ni kita nak buat. So kita akan ambil you punya value tadi. So your delta H1, which is 0.15 divide by 0.001. So kita akan dapat 150. Delta H2 equals to 7.5 divide by 0.0, this value lah, 03. So you akan dapat 2,500. And after that, kita akan tambah lah. So your delta H over U for your hot total. Total for your hot for section 2 is going to be 150 plus 2500. So kita akan dapat lah 2650. And this is that value. And you do the same thing for your cold stream. So cold stream ni hanya ada satu kan. So kita akan dapat dia punya delta H1 over U. So it's just going to be 7.65 divided by 0.008. So this value equals to 9562.5. Okay. So untuk this section, you akan dapat you punya delta H over U total, which is basically your hot plus your cold. So it's going to be 2650, which is this value, plus 9562.5. So you dapat 12212.5. And there's a lot of numbers I know, but this sebenarnya senang je. This sebenarnya just calculate using the value yang ada. So sekarang ni mungkin kalau you guys pening, don't worry. Sebab kalau you buat sesuatu, dia akan nampak lah. Lepas kita dah dapat dia punya delta H over U, then kita boleh calculate kita punya area. Okay. So tadi kita dah dapat. So for this, so I'm going to show you contoh for number 2 kan. So your area network would be your area network would be basically your delta H over U, delta TLM. So your total lah. So basically sebab kita dah dapat this value kan. So it's going to be 12212.5 divided by 25.3. So macam ni dapat 25.3 is kita calculate daripada this value lah. And then you're going to get 482.64. So ni baru area. So this is meter square. So you can check the units if you want. So ni baru area untuk this. Okay. So you're going to have to calculate the area untuk semua section yang ada. So daripada 1 sampai 7. So sebenarnya dia adalah just a procedural step lah. After that, kita akan, so this is what I meant kalau kita letak dalam table senang. So kita dah dapat delta TLM untuk section 1, 2, 3, 4, 5, 6, 7. Settle. Lepas tu cari delta H over U untuk hot. Tu delta H over U untuk cold. Lepas tu kita darab kan. Yes, sorry, bahagi. So this total bahagi dengan this value, kita akan dapat the area network. So semua ni akan dapat the total area which is berapa? Meter square. So please do try it out and hopefully you guys can see lah this value. Kalau korang malas nak cuba calculate sendiri, tapi I would definitely advise you to try to calculate lah. You can also try to use Excel, tapi you have to know which values to take lah. So kalau awak cuba sendiri baru awak akan nampak value mana yang kita nak ambil, berapa TCH dia, TC1 dia, berapa TH1 dia, macam tu lah. So dari situ kita boleh calculate dia punya heat exchanger network area. So kenapa kita nak relate dengan total cost? So ni contoh equation yang ada. So this one was in assignment 2 last semester kot. So kita boleh estimate daripada area tu tadi. So contoh lah area dia is 740998 kan. So let's say 7410 lah kan. 7410 meter square. So dia akan darab dengan 700 tambah dengan 15000. So this would be your capital cost lah. Berapa banyak dollar. So sebenarnya you can calculate kalau dia punya delta T min is contoh dia 10, 15, 20 and you can see berapa banyak dia punya total capital cost. And that would lead to your lowest total cost lah nanti. Sebab you have to consider you punya energy cost and you punya capital cost. So that is basically what you want to see for this particular chapter. So dia macam tunjuk lah macam mana cari your best delta T min from your trade-off. And you can actually predict the heat exchanger network area. So you can basically set it and trade off before you design. Itulah macam saya cakap seorang pula. Semua okey ke? Any questions tak?
So far okay, Doktor?
So far okay Alhamdulillah. So if you feel like macam tak dapat tangkap on step tu, so that's okay sebab dia sebenarnya bermain dengan calculator lah basically. So if you the most important bit kat sini is untuk kita tahulah macam ni kita nak identify dia punya temperature and macam ni kita nak identify dia punya CP. So please do have a try. Ni sebenarnya adalah soalan, is it soalan? I think it's soalan hari tu. Betul? Okay, tak, bukan soalan. So try to do it yourself and try to see if you can actually get the same total area. And if you can, then that's good lah. So itu saja untuk chapter 4. And your assignment is going to be released sometime this week. I forgot what day. could be Friday kot, and it's going to be due nanti lepas MPA kot. But it's going to include all of chapter 1 sampai chapter 4, so it's going to be a good practice lah for you. Your midterm is going to be chapter 1 sampai chapter 3. So basically tu sahaja. If there's no questions, so memang tak ada. Yes, no, maybe.
Ada, Doktor.
Ada, alright. Thank you very much for the response. So if there's no more questions and everyone's happy, so let's end the class with tasbih kafarah and surah al-Anas. Kejap. I need to get your attendance. Kejap. Okay. So thank you very much everyone and have a nice week ahead.